Isomerism and isomers. Two or more compounds with the same molecular formula but different structure and properties. Properties include both physical and chemical or both. So compounds exhibiting this property, this phenomenon, same molecular formula but different structure and property. This phenomenon is called isomerism. The compounds which exhibit this isomerism property are called isomers. The difference in the properties are due to the difference in the bond conductivity and spatial arrangement of atoms within their molecules. Isomerism, the concept of isomerism broadly classified into constitutional isomerism and stereoisomerism, that is structural isomerism and stereoisomerism. Isomers, same molecular formula, different structure. The structural isomerism or constitutional isomerism due to difference in bond conductivity. What are the types of it is chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism, ring chain isomerism. Stereoisomerism are same in bond conductivity. That's again classified into configurational and configurational, that is geometrical isomerism and optical isomerism. So now we are going to see the types of structural isomerism, constitutional isomerism. What are the types of isomers? Same molecular formula but differ in their bond sequence. That is structural or constitutional isomerism. The first one is chain or nuclear or skeletal isomerism. Similar molecular formula but differ in the carbon chain. The carbon chain is called chain or nuclear or skeletal isomerism, that it may be of straight chain or branched chain. For example, pentane, methane, ethane, propane, butane, pentane, N-pentane, straight chain structure. And here the isopentane, the isomer of pentane, one methyl group as a side chain. So 2-methyl butane, so isopentane. So here another form, isomer of this one is 2-methyl 2-methyl 2-dimethyl propane, it's a neopentane. So the pentane molecule, the different forms of pentane due to difference in the length of the carbon chain is called chain or nuclear isomerism or skeletal isomerism. Next one is position isomerism. Position isomerism is due to difference in the position of the substituent or functional group or an unsaturated linkage. The position of unsaturated linkage is called position isomerism. Same molecular formula differ in their functional position of functional group or position of the substituent or position of the unsaturated linkage. For example, pentene, here 1, 2, 3, 4 pentane but double bonded pent 1-ene, and here it may be of pent 2-ene. The position of the double bond is changed. Pent 1-ene and here it is pent 2-ene. C5H10, molecular formula C5H10, pentene. The same molecular formula, difference in the position of the unsaturation. And here the methane, ethane, propane, butane, chlorobutane, here 1-chlorobutane, here it is 2-chlorobutane. Changes in the same molecular formula, difference in the position of functional group, called position isomerism. So chain or nucleus skeletal isomerism, same molecular formula, difference in the length of the carbon chain, and position isomerism, same molecular formula, difference in the position of substituent or functional group or difference in the position of unsaturation. Next one is functional isomerism. What is functional isomerism? Functional isomerism possesses same molecular formula but differ in their functional group present in them. For example, general formula C2H6O, we can write two functional group, ethyl alcohol and ether. So dimethyl ether C2H6O and ethyl alcohol C2H6O. Same formula, different functional group. One is ether and another one is alcohol. C3H6O, CH3, CH2, CHO. So propanol aldehyde group, the propanone CH3CO CH3, both are C3H6O. Propanol aldehyde group, propanone ketone group. So same molecular formula differ in the functional group are called functional isomerism. The next one is metamerism. What is metamerism is same molecular formula, same functional group, a difference in the group attached on either side of the functional group is called metamerism. So C4H10O methyl propyl ether. This methyl propyl ether can be written as one side methyl group, another side propyl group. The group can be changed with the same formula on both sides ethyl, diethyl ether. The propyl group is isopropyl, methyl isopropyl. The difference in the length of the carbon chain. Here the long chain propyl, here the side chain isopropyl. CH3O, the isopropyl group. So same molecular formula, the difference in the groups on attached on either side of the functional group is called metamerism. So C4H10O, the metamerism. The metamers are, these are all the metamers of C4H10O. So arises due to the unequal distribution of carbon on either side of the functional group or different alkyl group attached to the either side of the same functional group and having same molecular formula is called metamerism. Next one is Tautomerism. There are three types of tautomerism given here. The tautomerism is due to single compound exists in readily interconvertible structure that different in a markedly relative position of an at least one atom nucleus. Generally that is hydrogen. The two different structures are called tautomerism. This phenomenon is called tautomers. The phenomenon is tautomerism. So the type of tautomerism, diet triad system. So diet system, hydrogen cyanide, HC triple bond N. That can be, hydrogen can be interconvertible and get attached to this nitrogen. So changed as HN triple bond C. Hydrogen cyanide, hydrogen isocyanide. So the hydrogen oscillates between two atoms. The two learned same formula directly attached to the polyvalent atom oscillates between the polyvalent atom is called diet system. Next one is triad system, the exhibiting keto and enol form acetaldehyde CH3CHO. Here the position of hydrogen can be interconvertible. CH3CHO, hydrogen comes over here, transfer over here, thereby it becomes here, it becomes the CO minus, so keto form. So if it transferred here, the hydrogen also changes here, converted into CH2 double bond goes here and hydrogen comes here, thereby OH, this one is enol form, keto enol tautomerism, change due to change in the position of hydrogen atom, due to change in the position of hydrogen atom between three atoms. This one is called keto enol tautomerism. So triad system example is keto enol tautomerism. Here the enolization process in which keto form is converted into enol form. Both tautomeric forms are not equally stable. The less stable form is known as liable form. Keto enol tautomerism triad system. Next one is nitro-acinitro form. Here also HONO, N double bond O. And nitro form, here the position changes, nitro form, and here the acid form. HNO2, here the nitro form and acid form tautomerism due to change in the position of hydrogen. So comes under triad system. Next one is ring chain isomerism. In this type of isomerism, compounds having the same molecular formula, difference in the bonding of carbon atom to form open chain structure and cyclic structure. So propene, CH3CH double bond CH2, propene and cyclopropane. Same formula, different structure. Cyclobutane and methyl cyclopropane. Propane, methyl group attached, cyclopropane. So the same formula, difference in the ring, carbon chain ring is called ring chain isomerism. So tautomerism, different type of tautomerism, diet system, triad system, nitro-acinitro form and ring chain isomerism. And the structural isomerism types of chain or position isomerism, position isomerism, functional isomerism and metamerism. Subscribe for more videos. Thank you.